This project revolves around a DC millivolt meter with a Nixie tube type display. Now this millivolt meter has a maximum range of 1 volt, but we're going to use the 100 millivolt scale here so that our decimal place is right there to kind of signal where the break between hours and minutes are. We've got our 0 adjustment, which as you can see I have set a bit high to compensate for the circuit's losses. And then the calibration, I'm not sure what this is different from the actual 0, however that needs to be as close to 9,000 as you can get it. I'm not going to bother tweaking it right now just since I'm explaining things. For those of you who don't know what a Nixie tube is a low pressure gas filled glass tube that has several filaments on the inside for different characters, in this case numbers. When the filament is energized with about 140 to 180 volts, it'll actually glow due to the heating of the wire, releasing electrons into the gas, which causes a discharge as the energy levels shift. And as you can see, it actually adds some depth to the display. Okay, so here's the circuit. It's pretty straightforward. You've got your Arduino right here, your voltage dividers up here. Each one of these pins controls a different aspect of the clock's output. Now you'll have a wire going out for controlling the first digit of the hours, a wire going out for controlling the second digit of the hours, then the minutes output, and so on. You'll also see that these are no longer connected. In fact, I'll go ahead and take those out. They used to be for the 0 correction for the meter that I no longer use, but you can find in my documentation if you're curious. So this part of the circuit actually will scale the 0 to 5 volts output by the Arduino to the range that is acceptable for what a clock should have if you were to look at a digital clock. Okay, so as you can see, you've got your voltmeter running here, your Arduino and your voltage divider right here, and you'll notice that I have it set to refresh the screen extremely fast. Now you'll notice it's got a lot of flicker in there. On millivolt scale readings, you'll end up having lots of decimal places beyond what this can read that pile up on top of each other and eventually cause a 1 carry right there. And also it's very sensitive to small fluctuations in the line that will end up feeding in. If you use some shielded wire, or maybe built this onto a PCB and put it in a box, then you'll be able to help reduce that. Now if you notice also, if I turn the refresh down, that slows down quite a bit, and this will be much more useful for operating as a clock, except occasionally you'll get a sudden jump of a few digits at 6 there, though for the most part it'll be just fine. And I'm kind of going for a Lord Veterinary style clock here, where it'll hopefully, if all goes well, drive my guests at my home mad. Well anyways, I just programmed the Arduino IDE up here to go ahead and set the time to 4:30. Now, it is uploading to the board, and if all goes well, you'll notice here we got this bit of voltage in there when there should be zeros going out to everything. That's just what leaks into the pins from the Arduino in other cases. And then you'll see that I just programmed in 4:30, but it's only giving me about 4:19, 4:20. This is because I have not set the 0 yet. Now, there are 2 ways to go about this. You can either use an additional pin on your microcontroller to output a voltage that will help adjust for the 0 of the meter. In fact, if I go to 0 there, you'll see it's not perfect. And I want about 4:30, and I was given about 4:15, spent about a minute, so 4:31. So I want to actually add about 15 millionths of a volt. Did I say millionths? Sorry, when you're working in millivolt scales, it's kind of hard to do. Oops. I don't know what this extra bit of the knob does, but it's very odd. So I'm going to actually bring this up to about plus 1.2. And we'll see if that will correct out to about 431 or 432. See, now we're about 431, 432, which compensates for the minute or so I've been talking about this to explain it. You see, you'll still get your fluctuations in there, but turn the refresh rate down, and for the most part it'll go with the average of what it receives, which is closer to the actual time. Again, your minutes will always fluctuate when you're dealing with this low of voltages due to anything that pops in. It could be the noise in both of my monitors here, it could be noise from the bulbs in the ceiling, keyboard, it could just be the fluctuations coming in from the data lines in the USB.